the red subscribe button right under the video and also the bell icon to get notification on any of our latest updates on the videos.
Hello everyone. In our today's video, we are going to calculate the reduced level of some points using height of instrument method. So we have a question here that says, given the following data in the table below, times the reduced levels of the point 1 to 6. We have point 1 to 6 and a benchmark. And we know our benchmark is a fixed point of a non-reduced level, as given in the questions, as 153.46 meters. So first of all, we have to find our height of instrument. And our height of instrument of the benchmark plus the back side of the benchmark. So our height of instrument is the same thing as 0.46 plus meters. So now our height of instrument at benchmark is 163.57 meters. So therefore our reduced level at point 1, let's say H1, same thing as height of instrument at benchmark minus our intermediate side at point 1, the value given here 3.25. So we'll have 163.57 minus 3.25. So our H1, this implies that our H1, the reduced level, 0.1, is 163.57 minus 3.25 is equal to 160.32 meters. Similarly, since point 2 is within this section, because from the question we can see that we have here is a section 1, here we have a change point. That means we have to calculate the height of instrument at this point 3, because it's a change point. There's a change in the position of the instrument. So here we have section 1, we have section 2 here, we have section 3 here. So the first section, they both have the same height of instrument at this section. Let's say section 1. The height of instrument remains the same for all the observation in this section. So height of the reduced level of point 2 is also height of instrument at the benchmark 63.57, height of instrument minus this intermediate side at point 2, 1.10. So therefore our reduced level at this point 2 is equal to 162.47 meters. Our reduced level at point 3 is equal to height of instrument at the benchmark minus the pole side. In this case, since we know our reduced level is height of instrument minus either intermediate side or pole side. So in this case, we have pole side, which is equal to pole side of point 3, which is equal to 163.57 minus our pole side at point 3 is 0.35 minus 0.35. Therefore, our reduced level 2 meters. Here we have 162.47 meters, 4.2. So since here there's a change point at point 3, that means the instrument position was changed during the observations. Here we have a change point because we have both the back side. We have both the back side and pole side at this point 3. Back side and pole side. So therefore, this is a change point. We can write it in our remark. This point is a change point because we have both the back side and pole side. So in this case, it also section 2 is the height of instrument now at point 3, the same thing as the reduced level of 0.3 plus the back side 0.3, which is the same thing as 163.22 at 0.3 is 6.89. So we have 6.89, which is equal to 170.11 meters. This is our height of instrument at this section 2. So our reduced level of 0.4 is the same thing as height of instrument at this 0.3 minus our intermediate site at 0.4 here, 3.14. We have minus our intermediate site at section 4, at 0.4 at 0.4, which is equal to 170.11 minus our intermediate site at 0.4 is 3.14. So therefore our reduced level at 0.4 same thing as 166.97 meters. So our reduced level at this 0.5 will be height of instrument at 0.3 minus our pole side, and we can see here also we have both the back side and pole side. That means our 0.5 is also a change point or turning point. So our reduced level of 0.5 is the same thing as height of instrument at 0.3 minus the pole side of our 0.5, which is equal to 170.11 minus 3.65 here. The pole side at 0.5 is 3.65. So final answer will have our reduced level to be 166.46 meters. So since 0.5 is a change point, we have to calculate. That means that the instrument position was also changed here. So you have to calculate the instrument height at 0.5, or height of instrument at 0.5. We need to calculate it so that we can determine the reduced level of this 0.6. So now our new section, our section 3. We have our height of instrument at 0.5 is the same thing as reduced level of 0.5 plus back side 0.5. Our reduced level is 1.66.46 meters here, plus our back side at 0.5 is 11.87. So we have plus 11.87. So our new instrument height will be at this point is 178.33 meters. Therefore our reduced level at 0.6 the same thing as height of instrument at 0.5 minus the pole side at 0.6, the last reading, which is equal to 178.33 minus our pole side at this 0.6 is 5.98. So we have 5.98. So therefore our height of instrument is equal to 172.35. This is the reduced level of 0.6. So now we calculated for all the reduced level between 0.1 and 6. We have 160.32 for 0.1. 0.2 here we have 162.47, 0.3 163.22 meters. 0.4 we have 166.97 meters. 0.5 166.46 meters, and our last point 0.6 we have 172.35 meters. So thank you for watching. See you next time.